topic today is Mastercam's add-on Productivity Plus, and it's created by Renishaw, and it enables you to do offline to program offline for your probing routines. So if you run any of these machines, you're probably aware that there's ways of programming them at the control for setup purposes, things like that. But there's also an option with Mastercam to let you program those offline the same way that you create your cutting routines. You can also create inspection routines offline, and you don't have to tie up time on your machine tool and programming these at the control. That's the beauty of this, and it's not only for doing simple resetting of G54 work offsets, but there's a lot more that it enables you to do as well. To start off with, just wanted to let you know who all is on the webinar here on MLC side. Myself, Ryan Green, I'm the Mastercam product specialist here at MLC CAD Systems. Formerly, I was Mastercam sales and applications in the Central Texas area, but I've since taken on a newer role, covering all of our territories on product specialists scenarios, mainly things to do with mill turn, multi-axis, and some probing as well. But I come from a applications background, so it's really a good fit for me. Also on the webinar is Scott Lindsay. He is our Mastercam applications expert in our Salt Lake City office. He will be the one fielding your questions, answering things as we go along. And if you haven't spoken to Scott before, he's one of our top-rated problem solvers. So if you called in or emailed to our Mastercam support with really tricky issues, Scott, he's just one of the best for figuring things out. We're definitely very lucky to have him on our team. Also on our webinar today is Marcus Brown. He is on our marketing side of the business. He's our content strategy specialist. But now let's go ahead and get into the content, what we had to show today, and that's with the Productivity Plus software. So as you probably have seen in our invite, this product enables you to do a lot of really great stuff. The most obvious one, is the automatic update of your work offsets. So as you're running from one part to the next, and you want to make sure that the part is accurately located in the machine, this product allows it to do automatic update of work offsets. In this picture, I'm just showing you G54 offsets, and for machines that are Fanuc equipped, or Haas machines, for instance. But this product also applies to Okumas. Okumas use H offsets. This works on that as well. Some BMG Mori machines, you name it. This product, it's meant to really let you utilize these probes to their full extent. And what's really great about it is it lets you maintain these tight geometric tolerances from run to run. So if you imagine after each setup for your first part, everything checked out great. You take that part out of the machine and then you load the next one in. There's always a degree of imperfection. I mean, that part won't go in exactly the same as the last time when it comes down to 4 or 5 decimal place accuracy. And being able to probe from run to run just really helps to limit the amount of deviation that you're really having to deal with on things. Now, besides updating for work offsets, this product also allows you to do automatic corrections for tool diameter and length offsets. So as you run your part and you have features that you're cutting with your tools, it's important to be able to take measurements of that and adjust as you go along. Manually, you guys do that just by using your inspection tools, calipers, micrometers, gauge pins, whichever, and then you manually have to make those changes with the machine. And that's great. That's part of being a machinist. But this part allows you to automate your machine to do that on its own. So if you've come across scenarios of you have multiple shifts, working at your place of employment, and maybe someone has a different attention to detail than you on certain things, or you want to make sure that you can come in the next morning and shifts 2 and 3 didn't just run piles of bad parts. This will this gives you really good assurance to help you avoid that. And I'll show this live during a demo in a bit. The next thing that kind of goes hand in hand with the automatic correction for tool wear offsets is how this product makes it really easy to create conditional statements. And I'm referring to things like in your program for if, then statements, go-tos, else, things that make the program have the logic to know what to do from one to the next. And writing that stuff manually can be a bit tricky. It's not impossible, but this product really makes it a lot easier for you to be able to do those things. And some other things I haven't shown here that I plan on showing in the demo. You can also have it, reprobe your tools. Basically go and retouch off from run to run. There's options for tool breakage detection to make sure that if there's something that's not right, it'll flag the machine to know that you need to change a tool. That's a really handy thing. If you're running through some really tough to machine materials and your roughing tool broke, well, if you let that machine continue to run, it's just going to tear up every tool after that. Using this product, you can go and set conditions after it's finished roughing, have it do a tool touched off for a breakage detection, and if it exceeds a given tolerance you give it, it just stops the machine. Or in the case of machines like Okuma's, for instance, you can do tool groups. You can have it call to another fresh tool to continue running. So this product really allows a lot of flexibility for keeping production going at a nice rate. So when it comes to the live demo part of this, I've got this part file that I'll bring up here in a moment. And what I've got is just some sort of a faceplate that I sketched up. I just drew up something that looks similar to a part that you may be running at your shop. We can see that the XY0 is located at the lower left corner, and I picked this one window, for instance, out of the part, and let's say it's got a pretty decent tolerance, or decently tight tolerance in length and width, as well as the depth. And let's just take into account that this part's already been machined on the bottom side first. So when we load this up, it's very critical that we locate the part accurately. That we touch off G54, X, Y, and Z. But imagine if you're working on a fixture plate, and that part, even though you had it pushed up against the dowel pins, when you tighten the clamps, let's say it just moved off slightly. So now you've got a bit of an angular error involved. And if this position, if the true position of this pocket feature is, 1,000, for instance, and you're just a tad bit off in your angle, then, the part's scrapped. So in this product, we're going to have it not only update for the G54 XYZ location, but we'll do a rotational update so that it outputs a G68 to our program to allow for an angular correction, and thus giving you the confidence that even though the part could be potentially loaded off the pin a bit, it'll be, still run within tolerance. And then as we go through this, we'll cut the feature, and then we'll do in-process inspection, check these settings to make sure that the part is right, and if we need to, we'll update it. So the next slide, I'm zoomed in a little closer on this. So you can see on the length and the width of this pocket feature, we've got plus 2 thousandths minus nothing. Then on the depth of it, 0.298 plus or minus half a thousandth. These are the kind of things you run into in machining. I mean, machining by nature, it's a very precision process. And when you've got tolerances like this is the kind of thing that you have to really stay on top of it on the machine to make sure things are run accurately. And if things aren't run accurately, like if it's run out of position for your true position tolerance, then the part's no good. It really leads to a lot of wasted money very quickly if you're not careful. What I intend to show you with this product is that this allows you to have the confidence that you can actually walk away from the machine and know that it's running accurately. Now, I'm not saying that you don't have to check your parts at all. I mean, there's still no substitute for checking them manually, but just this gives you the confidence that the machine is checking itself. So let's go ahead and get down to it and have a look at how this product works. Excuse me. So here's the part file that I had in the slide, and we're going to start off by just setting our G54 XYZ location at this lower left corner of the part. So to do this, the first thing I want to do is draw some geometry to help me place the probe positions a little more easily. So I know I'm going to be probing for a G54X and a G54Y. And I'm going to do this by just drawing simple lines. I'm going to start by drawing a line to represent where I want my X to probe in from. So I want to make sure that I'm in a 2D mode. I'll set my Z placement about the midpoint of this edge. Just when I'm drawing, it draws it down at that position. So I'm going to draw a line first. I'm going to offset the beginning point of this upward from there about ½ an inch. And I'll click, and that sets my first point. And I'm going to draw that line straight out at a length of, we'll say, ½ an inch. So, this gives me a starting point and an end point for that. So now that I've got that line drawn in, I'm ready to do some probing on this. So with Productivity Plus, it is an add-on to Mastercam. You have to purchase that add-on to run within the software. And if you have that add-on or not, you'll still see the probe button. You'll find it on the Toolpaths tab when you're in Mill. If you click it and you don't have a license, it'll just tell you that you need to get a license first. But here we've got what we need, so we'll keep going. So when I click the probe button, the first thing it asks me is to select a probe. And this is where you can build a probe for your specific machine. This one, for instance, I'll just click the edit. This is where you can tell it, specific name, as well as the tool number that you got it loaded in. And with these probes, you typically leave these in the machine. They'll be loaded in some tool number that's towards the back end of the carousel or however your machine is configured. But this is where you tell it what tool number that tool is assigned, as well as the length offset number. Imagine when you're on a Fanuc machine, you've got your G43 line with the H offset. Just think of this as being the H offset for it. The probe module, this is a Renishaw part number, and you click that drop down, it has all the various probe module names for Renishaw products. In the case of a Haas machine, it's usually an OMP40. And then for the stylus, this is where you choose what ruby or what diameter stylus you have at the end of it. And this goes by the Renishaw part numbers as well. This makes it really easy because the purpose of all this is so you get an accurate 3D representation of the probe. So when you're backplotting, you can see if you've got clearance issues, see if you maybe need to consider getting a probe extension or a longer stylus. Or if you're working on small parts, you may see that, hey, I can use a much shorter stylus. The shorter that is, the better feedback you get. Just the longer it gets, the more that tolerance starts to vary when it comes to super precision. But the idea is you just choose a stylus out of here that represents what you're really using, and then that's it. You just click the OK button, and it shows probe in here. You can also build other probes if you have more specific, maybe you have more than one probe to the machine. You may have a probe that has a 6mm ball, and then you may have another probe that has a little 2mm ball if you want to get into really small features. Just think of this as your tool manager for your Renishaw probes. So then we'll click OK to that. We'll continue on. And now we're ready to work with creating a probing routine. So this is the interface when it comes to doing probing. If you first get this product and for some reason it's just scrunched together like this, no big deal. You just grab that lower right corner, stretch it out, make it where you can see what's going on. But this is everything that we need to work with to make probing routines in Mastercam. We have our typical commands like cut, copy, and paste for quickly copying routines and making different changes to it. We have a button here for configuring the probe. This configure button, this things we go over more so when we do our implementation on site with the customers on it. But this is where we can set, what Renosol machine file we're working with. This is basically the post that controls for the specific machine we're on. In this case, we're on a Haas, so I'm just going to leave that as it is. And then next to that, you got your measurement routines. We've got point measurements, line measurements, circles, different features, stuff like that. And this is all stuff to, just a second here. This is all stuff to do with just making physical measurements in the machine. Next to that, you've got the options for making constructed geometry. We'll talk a little bit on that here in a while. Got a good scenario of that when we go to measure for our depth. And then after we've collected our data, we've got our functions for what we do with the data. Things such as machine updates, a G-code block. When it comes to calibrating, that's we go over an implementation phase. We've also got the option for doing tool settings. We'll talk about that as well. And then we've got reporting. I think I'd seen a question earlier. Someone had asked about being able to capture the data that you probe on the machine and then export it as a CSV. That's exactly what the reporting does. You can export that data through an RS-232 connection or however the machine is fixed up to a file and be able to do stuff with that. But anyway, let's just go and get started. I'll cover the other things as we go along. First thing I'm doing is setting my G54XYZ location. So what I'm doing is I'm going to probe a point, and that point, that's why I drew this line. When it contacts this point, that's what I want to use to set my X0. So I want to press enter to that. And so based off the point I gave it, these are the values that it has. So back up just a bit, go by inspection cycle first. I want to make sure I'm probing relative to my top plane, which I am. But that point, these are the values that it got based off that point. Now, I see these values look a little skewed, so it tells me I probably need to reset my origin point. So I'm going to X out of that real quick. Just going to quickly set my G54XYZ origin to be at this point. I should have done this to begin with, but that's a good thing about this product. We're seeing that we need to make a change now. So I'm going to go ahead and do that. And we'll call this our off one plane, and we'll make that be our active work coordinate system. So now that I've done that, we'll try this again. I want to go and make a new probing routine. There's the probe we're using. Now I want to measure that point, and that point, again, it's going to be this position here. I'll back up a bit, make sure it knows that we're going to be using an off-one construction plane. And when I look at the points given, these are the values that are assigned. So now it makes a little more sense. So the point position 1 is where we're actually contacting the part. The approach point, I want to make sure I set that approach point to be this end of the line. That's why I drew this out here, so I can capture that value so we can feed it in along that vector. So now that we've measured that point, I need to tell the machine, or tell Productivity Plus what we're doing with that data. So with that point we measured, I'm going to do a machine update. That's what that NC button is. And what we're doing is a work coordinate system update. You can see you've got different options to choose from here. We've got various others that we'll come across here in a little while, but we're going to do a work coordinate system update. And I need to tell it what feature am I using to make this update on. Well, that feature, if I click in here, I can choose this button at the far right, it gives me a list of features I've probed so far, and all I've got is point 1. Well, it knows at that point I can update the X offset, and that's it. I just click the green check. You can see now when I backplot it, it shows just like a normal toolpath backplot, it lets you see the probe doing its work. We go in and zoom up close at it. You see that the point we picked, it knows to go off the stylus center, and we're just going in and hitting that point and backing off. And with it, we're updating our G54 X offset. So now we've got that. We'll go ahead and continue with the rest of these features. So I'm going to draw another line. And what I'm doing, I'm just holding my shift key and selecting that point while holding shift. That way I get the dynamic gnomon. And I'll just go and span it over to here. And I'll back it off to, let's say, 1/2 inch. And, or actually, this is my beginning point. So I'm going to go and draw it in line with that. And then I'll press enter just so I can draw that line straight out off of that. I'll draw this one at a length of 1/2 inch. And so we've got that now for probing wide. So I'll just go back into that probe routine and we'll do another one. We'll just probe a point. The idea here is just showing you how simple this is. You just choose the point where we're contacting the part. I'm going to alter that approach point so that it's at this point out here at the beginning of the line. And now that we've measured that point, we'll do a machine update. The feature we're using to update this time is point 2. Again, when I click that box, it just gives me a list of measured features I've gotten so far. So with point 2, it knows it can update the Y offset. Notice here there's an option here called null band feedback. I just have it at 0. But what this is, this lets you specify a tolerance that if the correction value it measures is any less than what you give it in here, it just ignores it. But I prefer to have it update every time. So I want to leave that at 0. While we're measuring it, why not just update? So good to go on that. When I regenerate it, I can go to backplot. And when I go to backplot, it just gives you a visual cue. And having this representation is very nice because imagine you had some clamps in the way, and you see you're going to have interference. Well, you see now before you get to the machine that you may need to go pick a different point or set a higher safety plane. Like right now, you can see we're only up. Looks like we're raising up only about 1 inch over the top of the part. Well, no big deal. You can go in and you can make changes to that. Right here, the safety plane height for this, so we'll make it 3 inches. And I'll do the same for that previous inspection cycle, make it be 3 inches as well. You just regenerate. So now we've got that, we can backplot and see that we've got the tool or our probe starting much higher. If you've ever worked with one of these probes, I'm willing to venture that you've probably dealt with breaking one of these styluses. I've done it several times in my time, but the worst one is bumping that head. If you ever bump that head into something, that gets expensive. And having the ability to see beforehand, if you need a longer stylus or an extension, that almost pays for this product. And really only about 2 or 3 instances. So it really starts paying dividends really quick, being able to probe all this up front. But we'll go ahead and continue. I need to set my Z0, so I'll just go ahead and draw this point. Instead of drawing a line, I'm just going to draw a point. Say, well, I want to set my Z0 somewhere over here near this pocket. So I'm going to I'm just scale along the X and I'll scale along the Y, and let's just get pretty close to it because we know this pocket's got a really tight depth call out. I would rather probe my Z0 near that rather than over here in the corner. So we've got that point selected. I'll just jump back into this probing cycle, and we'll do another probe, a point. We'll choose that guy we just drew, and by default, when you choose a point, it thinks you're probing in Z anyways. So you can see on the approach point, it starts at 1 inch over that point. So we'll just get a little closer, get more like a 1/2 inch away from it for the approach position. And then we'll do a machine update with this. we'll use that point 3 that we just picked for it. It knows we can update Z with it. And we'll click OK. Regenerate everything. And when I draw out all the paths we've got so far, this shows us the path that the probe is taking, get to that point, and then from there we're ready to begin. So really makes it really easy. And what we just did right here replaced having to go to the machine and write this out manually. So let's go ahead and fast forward a bit. Let's say that we've already created our toolpath to contour the part, know these features. But let's say that now we're to the point where we need to take care of machining, the precision features of this part. And this is where I know I'll have a lot of other toolpaths before it, but let's just say we're going to do a contouring toolpath, go in and do a precision finish around the inside of this. So I'm going to create that real quick. We'll say we're going to use a 1/4 inch end mill to do this. So go to my tool library. I'm going to find 1/4 inch end mill to create this path with. And because I'm doing a really, tight tolerance finish on this, I'm going to turn on, maybe a couple of spring passes, just so I can be certain that we're taking a few dead passes and we're eliminating any possibility of tool flex when it's cutting in here. So we'll choose OK to that, let it ride out the path. I'll go ahead and backplot it a few times just to make sure that what I'm getting is what I need it to do, and it looks like we're taking care of this. So this would be the kind of scenario where I would want to have that probe come back and measure this after it's run and see if we need to update our tool offset or not. Not only that, but if we need it to rerun, I'll cover that as the second part of this. So first off, let's just check this feature out to see if we're indeed in tolerance or not. So for that, I want to make a probe routine right after it. Instead of measuring points, I want to use this option for measuring a web or a pocket. So with this, the idea is you choose the mid points of each end of the feature. So the first point, I'm going to go and choose right there. And then the second point, I'm going to choose over here, the midpoint of this end. Now you can see that, it fills in the values, but some of these are red. It just means that I don't have enough data yet. So for the width, I'm going to select from this point over to this point, and it knows that's how wide that feature is. And you can see when we look at our tolerances, I've got +2 -nothing on the width and the length. So we're going to tell it we're probing on the inside of this. I'm not using a stock allowance. That would be like if you're using raw stock, but none of that right now. For the start-end clearances, it's going to probe at least two points along the length of this feature. And if we start at 0, we're putting it right on the edge of it. We don't want that. We want to offset it away from that. We'll say about 1/8 of an inch. Same thing on this side, do 1/8 of an inch. The inspection depth, where the stylus is hitting it at, this is where I would just plug in, say -3/8 of an inch. And keep in mind, that's to the center of the stylus. So now we've got this. Before I do anything else with this, I just want to backplot it and see if it's giving what I'm looking for. So I go to backplot it. Let's see here. Oh, first off, I can tell we're way too deep, so I need to go and adjust that inspection depth. So let's go do that real quick. So choosing on that pocket again, I can see what it is. That inspection depth is an incremental value with respect to the Z points that we'd picked for our beginning measurement point. So we're just way too deep. Let's try -150. And this is the kind of number that you guys can work with, so you get more like what you're needing it to do. There it is. It's hitting in a little lower. It's more like what we're seeing. One thing I don't like, I see how when it measures a point, it's making a diagonal move from it to the next. And that's because we're taught to use shortest direction. So, I'd rather not run it like that, the machine. So that's the beauty of this product. You can go back and make changes, edit this thing as you go along to give you what you're needing. We want to use linear mode. So I'm going to regenerate that. Now this gives us a little bit more of what we're looking for. So it's measuring 3 points along it, and it measures each end, and that's it. Now, if you're wondering about what's controlling the number of points it's measuring, well, that's controlled within the cycle. And see that this gives you various options, and I think you can probably tell that this is a lot more comprehensive of probing than what your machine even gives you. This lets you really get things down to to the nth degree with it. I mean, you can tell it. Right here's the number of points we're measuring, 3 points. Say you want to measure 6 points. If you want to get super accurate, make sure that you're checking, across an average of it. It just gives you unlimited potential on being able to be as precise as you want. So now we've measured that. The probe has found what the length and width is of this feature. So what we want to do is tell it to update the tool based off what it just measured. So for that, we're going to do a machine update. And in that machine update, the update type this time around, we're going to be doing a tool diameter update. So for tool diameter, what we want to tell it is what is the tool number of what we cut that feature with. And we're going to say it's tool 1. Or, this is where you plug in whatever tool it really is. Now the index, the edge number, think about this as, what D offset you're using when you're using cut or comp. Well, on a Haas machine, we usually use the same number as our tool. So we're going to set that at 1. And then the feature that we're using to update it, that's where we go and choose from our list of measured features. And here's that web that we just measured, or the pocket. And it knows we can either update the tool geometry or wear. Now this is where you want to keep in mind how you programmed your contouring toolpath, whether you're using cut or comp set to wear, which is where you're based on your machine, you set your diameter columns at 0, or if you prefer to use the cut or comp in control, so you can enter the actual tool diameter at your machine, that would be geometry. You just want to make sure you use the right one, so it's right in the right corrective amount. So we're going to set this to wear. That's what I typically train people to use, and then that's it. So when you've done that, that's going to run that feature, and then it's going to update the tool offset to make it right. Now, that's not going to tell it yet to go back and rerun it, though, if it's too small to go and update the offset, to first update it and then rerun, or if it's too big, we can just have it flag the machine that the part is scrapped. It's non-conforming. So that's what I'm going to get into here, on the next bit of this. So before I keep going here, I'm just going to expand my panel open, make sure I don't see anything. If anyone has any questions or anything, real quick though, I just still want to make sure everyone can hear me. So over on the right, in your control panel, just if you wouldn't mind, if you can hear me clearly, hit the raise hand button. I want to make sure everyone is with me. Wow, this is impressive. I've got 80 of you online with us, and that's awesome. I tell you, like when we're in these interesting times that we're in, and machining may be a little slow, and this is the ideal time to improve processes and that kind of thing. So I'm glad you all are with us today. I'm going to go and lower everyone's hands, and we'll just keep going. Looks like we have a question. Great. Good deal. All right, so while we keep going with this, so before I come back to updating for a tool radius, I talked about the analogy of, let's say this part was loaded off of the dowel pin at one of the pins on the plate. So now this part is sitting at an angle. Well, if we run the part like that, we're going to cut this out of position. And if we've got a true position of 1,000 with respect to datums A and B, I mean, it's going to be, you're wrong from the get-go. So I want to include into my probing an option to correct for the rotation of the part if it's loaded off like that. So to do that, in my original probing cycle up here, when I'm probing for X, Y, and Z, I'm also going to probe a line. I'm going to hit along the length of this to make sure that we make a correction for it. So before I do that, I'm going to turn my shading off, make it a little easier for us to see against this. What I need to do is I need to draw a line across the length of this part. And I'm going to start by drawing it from this point and drawing this over here. This line is what I can use to check for the angular orientation of her part. So I'm going to go back into my original probing cycle after we probe for X, Y, and Z, and I'm going to have it go and probe a line along the length of this. So that line, I want to choose what we just drew, and I'll press enter. So it knows the endpoints of that line. I can tell it what direction am I probing at when I'm probing it. So it automatically defaults to positive Y, but you got your other options here as well. The inspection depth, where I'm measuring it with respect to it. And then the other thing is I don't want my probe hitting on those exact corners. This is where the 0.1 and 0.2 clearances come into play. So let's say I've got my dowel pins a ½ inch in from, well, they can't be a ½ inch because that's where I probe. Let's say we got them in by, like an 1.5 inches, or, thinking out loud here. Let's say it's in by 1 inch from each edge. So I would probably want to probe 1.5 inches in, just so I can avoid hitting where those dowel pins are. And obviously I could have had that modeled in my file, make it more visual, but let's just say I know that I can probe in by 1.5 inches, and then the number of points I want to hit, I'm just going to probe 2 points. So with that said, I click the green check and I'll regenerate it. So in the back plot, what I'm expecting to see is, move this out of my way here real quick. I'm going to backplot this through X, Y, and Z probes. And I thought I had that line in here. Did I not have it? Yeah, I guess I never did complete that line, so let's do that again. Number of points, so we'll do 2 points on that. Our end clearances, make them be 1.5 inches. I want to make sure I don't have any red in here. If there's any red, then, oh, I see it, put that line in that inspection cycle. So, I don't want it happening where I'm probing Z. What I'm going to do is make a new inspection cycle, and at the bottom, I'm just going to drag it underneath that machine update, and then I want to drag that measured line down into this. There we go. And in this empty inspection cycle, we'll just delete that. So now that that's in there, I should be able to regenerate and see all of this happening. And yeah, there we go. So now when I backplot it, here's our X probe, here's what we're probing Y. Here's a probe for Z, and then we're going to check for that angular orientation, and that's that move we've got right here. So now that we've measured that line, I need to tell it what we're doing with it. And what I intend to do is a G68 rotation to control for that error. So immediately after that measured line, I want to put a machine update. And before I do that, something I'll point out, if you want to rename these things, you can. Let's just call it, line for G68. You can't put spaces, so let's say we'll put a underscores. And the reason I'm doing that is just so I can make it easier for me to, the longer this list of probe features becomes, the more confusing it can get. So I'm just going to have it written like that. Now we'll do a machine update. And for the update type, one of our update types is a rotation update. So the rotation update, the feature we're going to use to update it, you see now how it shows in here as that name we gave it. We're going to update for around Z. And that's it. It's simple as that. When you got that in your program, that will output all that command in your NC file to spin this guy around the 0 point to put it accurately where you need it. I think that's just so cool. you know, with machining, you know, inevitably over a long period of time, you just learn some things the hard way. And I mean, who hasn't loaded a part that didn't get just a little tweak off of the setup pin? This gives the assurance you can keep going. You got true position of 1,000, and you're having to cut this feature on a second or a third off. This gives you the assurance that you can put that right where it needs to be, and it's going to be made right. So I just think that's really cool. And something I'm going to point out is that rotation update, it doesn't only have to apply to G68s. If you have a 4-axis machine and you've got a part in the 4th axis that you need to accurately clock to a milled feature, this lets you do a probe in the negative Z direction to control for that. It also applies to 5-axis machines where you can do a rotation update about the 4th and 5th axis, and you don't have to worry about the part being off the line. Really cool stuff with this. So now we've got our G64 XYZ and orientation updated. Let's jump ahead back to this probing cycle, where we're probing after we run this feature, and we need to, we've already got it set to do a tool diameter update. But the thing is, as it's written right now, it's going to cut the feature, and it's going to measure, and it'll update it if it's in or out of tolerance. But it's going to keep going. And what I really want is to, in the case of if that feature came out small, I want this to go back and recut it. So that's what we're going to do next. So on this contour cycle, over here in my operations manager, I want to put my little red insertion arrow just above the pass where we're contouring it. And what I want to do is I want to make a point to restart from if we have to recut it. So to make that restart point, that's actually a probe cycle. So we go into probe, and in this probe, I'm not going to do any measurement routine. All I'm going to do is I'm going to create what we call a label. And it just labels it label 1. I want to be more specific. I want to rename this to restart or recut. And just give it a more descriptive name. So that's it. Just click the green check. That's all we do with that one. We just, the purpose of this is creating a point we jump back to if we need to recut it. So now that we've got that point put in, and we go and cut the contour around it, and we go to probing, this is where we want to change up this probe to be a little more intuitive. So I definitely still need to measure it, which is what we've got here. And this is where we get into the conditionals, the if-then statements. So across the top of this ribbon at the top of our probing window, this is where we have our conditionals at the end. We've got our if-then. So I want to choose if. And so on this if, I click on that. And when you click on it, it has what you need to get over here on the right. Well, for the condition, it has a red X because right now I don't have anything in it. So I want to go to this condition, and I want to choose, and this brings up a list of all the probe features that we've gotten created so far. And I know that web or pocket where we measured this window feature. And, if you're in the real shop environment, maybe you would want to rename this just so it kind of stands out. But if I expand open that web pocket, this is all of the data that was collected from it when we were probing, including the endpoints, the midpoint values. We keep scrolling, and then we've got the width and the length of it. Well, let's say I'm just going to use the width of this to update it. So I want to double click width. So basically it says if the width, and I set a condition, if the width of it is less than, and I want to, set a, pick a value. I know that the width of this feature is 3/4 of an inch plus 2/1000 minus nothing. So I want to type in the width of it is less than 0.750. And we're measuring less than 750. That means we're undersized. We need to update the tool. Click OK to that. So now it says if the web pocket width is less than 3/4 of an inch, then I want to do that machine update. I want to drag that machine update right on top of that then, so it becomes a child component of the then statement. Okay, so if it measured less than 3/4 of an inch, then we're going to do a machine update. And after we do that machine update, I want it to go back and recut that feature. Well, to make it go and recut that, that's where you go and choose over here on the right of the ribbon, you want to add a go to. So if I go to, that's where I tell it to go to whatever label it is I put in front of that finished pass. So right now it's just listed as label 1. I'm going to go and choose over here. I'm going to set, and this is why we renamed it earlier. I'm going to have to go to that restart for recut. And that's it. We click the green check to that, and we regenerate it. What's going to happen is when we go through and probe it, and it finds that it was undersized, it's going to do that machine update, and it's going to send it right back to that restart. And right after that restart is the finished pass. This is how you make your program recut that feature now. Pretty cool stuff. Pretty cool. This one really makes a lot of customers happy when they know they can have it check itself. So we've got the condition for if it was smaller than. Now, how about if it was greater than? Well, what happens then? Well, if it was greater than, it's just going to continue on out of this cycle, and it keeps going. And then it goes, cuts other toolpaths, just whatever order you got your operations in. Now, how about if it cut oversized? So if it cut oversized, that could be an issue. So that's where you would add, make sure you click on the if statement first, or then, I would add an else if. The else if the condition this time is, let's say the width of it measured too big. So say the width of that, if it measured greater than, or not greater than or equal, but greater than 0.752, which would be the top of tolerance, then, I would have it do some of our customer shops will have it do like a G code block where, see, where's our G code block at? Right there. And I would drag that G code block up into that statement, and this is where you can have it output the alarm on a HOS and say number 3000 equals, and then in parentheses 1, comma, and just whatever comment you want to display to the screen. We've even done scenarios where we have it jump to another subprogram, and it engraves the word scrap on the part. Makes it very apparent that the part's not good. In this line of work, we always want our customers to be happy with what we send them. We don't want our customers finding bad parts that we sent them and then having to call us on it to let us know we sent them bad parts. That's it's bad for your reputation, and it's easy for it to get out if things aren't checked. This gives you a means of quality control to control that. So this is an example of how to make it do a restart when that kind of thing happens. The next thing is, we have this pretty tight depth to control. It's even tighter than our length and width. So I may want to go and probe the depth of it, but I don't want it to just return a Z value at the bottom of that pocket. I want to find the difference between the bottom of that pocket and this point. That point may have changed throughout the run. So I'm going to go and draw a point to measure off of down here. And let's just say, let's just move it in off that edge by about, a 1/16 of an inch, maybe over a 1/16. And just picking a point at random to measure at. And I'm going to have it do a check on that. So I want to make a new probe cycle just to keep things a little simple. I want to do a new probe where I go in and I measure those 2 points. So earlier when I was doing G54 XYZ updates, I was just picking a point at a time. I can pick more than one at a time. So I just picked both of these, and it shows as measured points 4 and 5. I want to rename this one here. Let's say top of parts, and we'll rename this one the bottom of the window. And it knows that we're probing in the Z direction on these. And so, I need to find what the true, you know, distance is, in Z on that. So this is where we use the constructed geometry. It's this ones we've got here. So constructed geometry, I'm going to say construct a line, and for that line, I'm going to drag references in from those 2 points I measured. So between those 2 points, it's constructed a line. Now, right now, I know that line is diagonal, but what I want to do this time is control for our our depth setting of the tool. If we need to compensate for the length offset. So now we've got that constructed line to work with. We can do a machine update again. And this one, I'm going to do a tool of length update. And this, we know it's tool 1. It's offset number 1 we're using. For the feature we're using to update this, I'm trying to find, may have just shot myself in the foot here. Let's say we're going to base off the bottom of the window. Now that's going to update based off that bottom point. But this again is where I would probably want to create an if-then statement. So I want to create an if statement, and for a condition, I want to take that constructed line that we created and see, here's all the components of that constructed line that we got. And of course, you got the diagonal length, but notice you can also get the length in X, Y, or Z. Well, that length in Z, that represents, like if I'm using my depth mic to check the depth of, I'm going to say the length in Z. And this is where you use your conditional statements: less than, greater than, and you go by the tolerance given. Let's just say we'll use, if it's less than, I think it's 298. If it's less than 298, we'll just drag that machine update into here and let it do a machine update to control for the tip of that. And then we do another one if the, drag that afterward. Trying to drag it after the fact here. There we go. So this one, we'll say if that condition, if the length in Z of that constructed line is greater than, I think it's what we've got, 1,000 tolerance. So if it's greater than 0.2985, then we'll do a machine update again. But this time, it'll keep that tool comp basically to keep it in range of what it needs to be to maintain that tolerance. So I mean, having that's a really nice thing to have. So other things to talk about. I know we talked about the outputting the data. Let's just take like that window. That might be a precision feature you want to output the data of. Well, we'll go back to that probe cycle where we control for all of this. Well, if you want to output that data, that's where you can use the reporting option. So when you do reporting, this one you basically just drag a reference in of what you're wanting to report, or just have it output all the data it captured off of that web or pocket. And this is what will output the lines of code in your program. Like the note, for instance, it's the dprint command. You'll have to have a computer set to capture that data at the end. And something I'd mention is it outputs as a basic text file. But Renishaw, they have another software called Renishaw Reporting. It's where it's a software that captures it in a graphical format. Basically, like you'd imagine your CMM capturing this data, it lets your machine do the same thing. So if you want to do reporting, that's one way of controlling for it. Other things you can do is I talked about the tool breakage and tool wear detection. Let's say before you even run that probe, that window, let's make sure the probe or the tool isn't broken. So I'm going to put my red arrow up above it, and we'll do a probe cycle. So another thing you'll find in this probing is options in here for tool setting. So I click this drop down. We've got our broken tool detection methods, and this covers into more of the Siemens, Heidenhain, and Okuma methods. On this one, we're on a Haas, so that's a contact. It's physically contacting a little setter that we've got on the machine. Let's just say we're going to do a broken tool detection on this tool. Well, you tell it what tool number it is that we're checking, tool 1, offset 1. And then you can tell it, what type of detection we're doing, and then a tolerance. So this is where you plug in the value that if it exceeds this tolerance, then that means there's something not right with your tool. So 19,000, that's kind of generous. I mean, this was me, and I know I'm doing with a half a thousandth of tolerance. If I was any more than 1,000 difference from one touch off to the next, I would want to know. So you just plug that in, and that's what writes out the code for you to make that happen. And speaking of the code, let's have a look at what the program looks like. So I know that we obviously don't have a complete part program. There's a lot more features on this part to cut, but let's just post out what we've gotten so far. When you go to post this and you click on your G1 button, we go through typical post-processing steps, so where we want to save the NC file, and then it comes up with this window. This is unique to when you're using this product. This is the Renaissance step of it. So we just simply click the process button. It builds up a list of things here, and we're just looking to make sure that each of these steps succeeded. And looks like we're all good. So we'll go ahead and click done, and it finally launches in the editor. And this, make this a little bigger so we can see it. This is all the code that's written to make this happen. So you remember at the very beginning, we're touching off our X, Y, and Z. So all this code, imagine writing this manually. I don't want to do that. This is what this product is doing for you. And all these G65 macros and all these values passed to it, that's all the logic this is using to make this run like you're needing. So anyway, it gets done running all of the original probing, and then here's the code where we're going in and recutting, where we're cutting that window. And then right after that is all the code that has to do with where we're checking the width of it. So let's see if we can find it here. Yeah, right here, look at this. So it says if number 109 is less than 0.750, you remember that conditional we said if it's less than 3/4 of an inch, it go to 732. Well, look up here and right above that code where we cut the window, gosh, somewhere up here is where it's at. And it may be embedded in one of these macros, but I know it works because we made this work on customer machine that sends it right back to that flag we made right in front of all that cut. And then it makes it recut the window. It writes this all out manually for you, so you don't have to. And then at the end, after the M30, and that's our M30, it's right there. So after that is where it outputs all these macros it needs to run this program. And this will all load up separately on your machine's control. I know there's a lot going on, but just remember it's writing the code, so you don't have to. It's a lot more comprehensive than the standard program routines that you may have on your machine. So, the point is, let the software do the work for you. You don't resort to having to type your machine tool to write this out manually. I'm sure you all, have projects you work on that you have a lot of, some really precision features to have control for. This product really gives you the flexibility you need to get that done and get it done accurately. Let's see, what else have I think I've covered just about all we have to show on this. So I'm going to switch back to my PowerPoint presentation. I know we're right at the hour mark, or just a little past it. So at this point, we're, I'd like to thank you all for attending. Appreciate you guys taking time out of your day and visiting with us on this. At the end of this presentation, after we call at the end here, plan on sticking around for a bit where we can answer questions, any things that you may have. But once again, just want to thank you guys for your time, for coming out to our show. Like I say, there's very interesting times that we're in, but just think about it on the positive. This is the great time to improve your processes. In machining, I mean, we all deal with quality control. Productivity Plus gives you a means of automated quality control. So if you'd like to learn more about this, then please let us know. We'll be happy to speak with you on it. Let's put you in touch with your local team, talk more in depth on it. But that's it. Thank you guys for your time and coming out.